Let us start recording. Once we will start formally, then we. Today we are going to learn about more about time series. This session will be a practical one. We will be repeating some of their previous exercises like regression and all. So today's focus will be more about learning and how to interpret the results, output results. So I would like to invite Dr. Akanksha to start the session. Over to you, please.
Yeah. Thank you, sir. A very good evening to everyone. On behalf of the Jindal Center for the Global South, Jammu and Kashmir Economic Association, and Global South Research Foundation, I, Akanksha Kathuria, extend a warm welcome to all participants joining us from across the country and beyond to day 5th of this enlightening 7-day online workshop. So, dear participants, have you ever wondered how economics predict inflation, stock market trends, or policy with such a detail and accurate? It's not magic, it's econometrics. And more specifically, it is a time series econometrics. So, from forecasting GDP growth to analyzing stock volatility, time series is the pulse of the data driven research. And today, we are lucky to have one of the best in the field that will going to guide us today. So it's an immense pleasure to introduce our distinguished resource person for the evening, the powerhouse of the financial research and analytics, Dr. Silky Kushwah. Dr. Kushwah is a professor of finance at NDIM and a seasoned academic with over 20 years of experience in teaching, consulting, and research. Her work speaks volume with over 60 peer-reviewed publications in reputed international journals like Emerging Market Finance and Trade, Qualitative Research in Financial Market, and International Journal of Finance. From financial inclusion to energy finance interaction, from AI in finance to volatility spillovers, her research spans the most dynamic topics of the modern financial world. And guess what? She doesn't just write, she speaks, present, and lead with 50 plus presentation across IITs, IIMs, Europe, and Asia. She is truly a global thought leader. She is a mentor, a trainer, and an innovator too, leading funded projects by AICT and Impress, and currently pursuing her postdoc research on financial inclusion and healthcare access at MIT University, Dubai. Today, she's here with us to simplify the complexity of the time series econometrics and equip us with the tools that can take our research to the next level. So without further ado, let's welcome the dynamic, inspiring, and incredible Dr. Silky Kushwaha. Ma'am, we are honored to have you with us. So this virtual stage is all yours. Hand it to you, ma'am.
Thank you so much, Akanksha. A lengthy introduction, of course. Firstly, I'll really apologize for what happened with my, laptop. It went on update mode. So I've joined with another one, but all my files are there. So once we, just revise the concepts, I'll switch to that laptop where my, Excel and e-views are lying there. Okay, so I've just downloaded the PPT for you people. So I have been asked by Professor Firdaus to just give you a recap of what you have done on the first day and second day, couple of things on the third day on eView software. So first 1 hour we'll dedicate to that, and next 1 hour we'll be learning a new model that is a volatility model. You people must have heard about it. It's the Garch model. So what I'll try to cover today is a revision on your regression and an introduction to the Garch 1.1 model with real-time data sets. So I have already shared the data sets with Firdaus, and I've seen that he has also shared with you people. So we'll be applying it on the data set so that you people feel more comfortable with it. So let's just start. So, the content that we'll cover today is, the difference between correlation versus causation. And if you people have doubt, you can keep on writing on the chat, and I'll try to answer your queries. The other one is correlation analysis, a revision of correlation analysis, how to apply correlation on eView software. Third will be your regression analysis, how to apply regression on eView software. And then the assumptions of regression model, we need to understand this fact that if we just download the data from investing.com or screener.com and we simply start applying regression, the results will be spurious. So we first need to check multiple assumptions that are required for regression model to give you good results. So we'll just revise the assumptions, we'll apply the regression model, we will apply the multiple regression model, and then we'll just go through the results, what things we need to pick up while explaining the results for our research paper or for our PhD program, and then the residual diagnostics of regression. And the last will be forecasting using the regression results to check how good is your model with the actual values and the predicted values that you have done. So let's start the journey. So the first thing, that I wanted to discuss with you that many scholars of mine get confused is correlation and causation. So when two things are correlated, we all of us understand what is correlation, that when the things are related, their values change simultaneously. Now values can change in opposite direction also. For example, if one thing is increasing, the other may decrease. For example, if the RBI increases the interest rates, the repo rates, we might see a fall in the stock market prices. Okay, so the direction can be opposite, but correlation basically studies that if one variable is increasing or decreasing, what is the impact of it on the other variable. So it describes the size and the direction. If we remember the thumb rule, they say that if the value of correlation is between 0 to plus minus 0.25, it is low correlation. If it's between 0.25 to 0.75, it is moderately correlated. If it is 0.75 to 1, we say it is highly correlated. So we are all aware of such facts. But a correlation between variable does not automatically mean that the change in one variable is caused by the change in the other variable. I've taken very simple examples for explaining that causation is a different thing and correlation is an entirely different thing. So causation, as the name suggests, cause and effect relationship. So it studies that one event is leading another event. So it says that because of one event, the other event is the result of that event. So let's understand the difference. A very simple real-time example that you can see in front of you is that smoking, if a person is smoking, it increases the chance of lung cancer. Okay. And on the other hand, smoking is not cause has does not have a cause and effect relationship with alcoholism. But I say that's when usually people consume alcohol, they also tend to the smokers also tend to smoke. So there's a high correlation between smoking and alcoholism, but smoking does not cause alcoholism, or alcoholism does not cause smoking. But yes, smoking causes lung cancer, the increase in the risk of lung cancer. So this is one example where we can differentiate between correlation and causation. So when we are doing a research, we need to understand that we are trying to find out the movement of two things in finance and economics, or we are trying to find out at what one event is resulting to the happening of the other event. If it's the second part, then it is a cause and effect relationship that we want to study, which we cannot study using correlation, for which we have to introduce regression. So another example, interesting example that I give to my scholars is that, let's say it's a very hot and sunny day, and due to that, we see an increase in the sales of ice cream. So this is cause and effect relationship, that because it's a hot and sunny day, people, tend to consume more ice cream. So the sales of ice cream increases. On the other hand, if it's a hot and sunny day, it increases the chances of sunburn. Again, there's a cause and effect relationship between, because the sun is so high and it is so hot on us that it is resulting in sunburn. So we can see that the ice cream sales are also increasing. Simultaneously, the number of people having sunburn, that is also increasing. But can we say that ice cream sale is dependent on the number of sunburns people are having, or vice versa? No. There is no cause and effect relationship between the two. But when we'll calculate the correlation between the two, we'll see the correlation will be very high. So now, guys, we have a fair good idea that correlation is a separate thing and causation is a separate thing. Any doubt till here, anyone? Okay. So, the next thing that we need to understand is, why are correlation and causation important? Why do we study? So, I'll take some real-time example, recent 2025 example. We have seen that RBI has been cutting, the rates, the interest rates. Now there are, startups, there are entrepreneurs, there are consultants who are interested in knowing that does this RBI interest rate cut is resulting in startups, entry delays, is resulting in, people, or increasing the chances of people buying more, homes, because home loans are cheaper now. So such cause and effect relationships can be studied and give you beautiful results. I'll take a marketing example also, maybe some marketing people sitting here. So, we saw in 2025, Zomato introduced and spent a lot on AI companies, AI marketing campaign. So this AI marketing campaign was that as soon as the customer orders, the AI is involved in studying what kind of order the customer is doing, at what time the customer is doing order, what are the repetitive orders that the customer do, what are the days in a month when the customer does order. And then, maybe they can send prompts, or they can send the campaign things to the customer during those time periods, when they see the AI has picked up that these are the time periods, these are the dishes, and etc., that the customer uses or orders on Zomato, which will increase what? Which will increase customer retention. So in order to study that, does AI marketing campaign on which they have, spent tremendous amount, increases customer retention. It's very important for the companies to understand that. So not only from the research point of view, guys, that we have to write research papers and we have to get it published. It's also from the, the business point of view, the company's point of view, the consultancy's point of view. We need to understand the relationship between various important variables in the corporate world, and there is the place where correlation and causation are introduced and the relationship is checked. So we have already done this. Just a recap, if you want to, calculate correlation on e-views. So my focus will be on e-views today. So what you usually do, most of you know the answer. You open both the, time series. So I picked up time series. So if you will open both the time series and you go to view, you go to covariance analysis, and you select correlation and the probability values, and you click OK. This is the result that you get it. So we'll be practicing that after maybe 15-20 minutes. We'll do the exercise where we calculate correlation, we calculate regression, and we discuss the results. So are you people comfortable calculating correlation on e-views? Just a thumb will do. Okay, I see only one participant answering. I hope others are not sleeping.
Yes, madam, I will do.
Yes,
Okay.
ma'am.
Thank you. Thank you for your response. Thank you for your response. Okay, so we can certainly skip this slide and we can move to the next slide. So now it's regression analysis. Just a quick recap of what you have done on the first and the second day. We know there are three types of modeling techniques. Can anyone name those three types of analytics techniques that we use nowadays in research? Some people are still writing no for correlation. It's okay. We all will be applying that. Anyone who has an idea about three types of analytics or modeling techniques that we use in research?
Time
So,
series modeling and
okay,
panel regression modeling, and another one is
cross-sectional.
cross-section modeling.
Yeah. So, whosoever answer, it's a beautiful answer. But let me tell you, these are the types of data. So we
Based
have
on
panel
based
data.
on data, madam.
Yeah. So we have panel data, we have time series data, and we have cross-sectional data. And based on those, the kind of data set you have to apply different models. So, indirectly, the answer is right. That if it's a panel data, you cannot apply the test of time series data on e-views or stata. If it's a time series data, you cannot apply the cross-sectional models on that. So we have to first understand what kind of data it is. Can anyone tell me the difference between time series data and cross-sectional data by just writing on the chat box? Time series data and cross-sectional data. I am side by side trying to start my laptop. Yeah, anyone? Time series data, because you have been doing time series, you have been doing econometrics. So, anyone? Time series covers multiple units at a single point of time. No, not at a single point of time.
Time
Sayed.
series time series over a period of time, madam.
I'll suggest you people to write instead of opening your audios. Okay. Over a period of time, Minju is right. Time series deals with single entity over the period of time. Okay. Single variable. Can there be multiple variables? And then you say that there are multiple time series, Archana? Time series studying different variables
No,
at
madam,
different.
it is panel data, madam.
Yeah, so yes. So, time series, you people have guessed it right. Time series is something when you have, one variable number of observations over a period of time. So, if I tell you that I am trying to, capture the gold price on first of every month for last 5 years, I am trying to capture the gold price on first of every month for last 5 years, then I'll say it's a time series. Why? Because there are two things. One is that, the data that I'm fetching gold price is over a period of time for last 5 years. One important thing for time series. So last 5 years, so every year 12 months. So 12 into 5, 60. So I have 60 observations with me of gold price. The second important thing that is important for time series. Anyone? Can you just write it on the chat box? So over the time period is a very good answer, guys. Everybody knows it. What is the second condition for time series? Can you write it on the chat box? No, no. See, Shushma, you are right. The time series has to be stationary. But in order to be a gold price series, to be called as time series, it's not necessary that it has to be stationary. Yes, Akhil is right. The interval has to be equal. The interval has to be equal. For example, no trend required, nothing, no stochastic. No. We are going very far. See, a very simple thing is over a period of time. Everybody knows that. So last 5 years, monthly data I'm studying. Every first of the month, 1st January, 1st February, 1st March, 1st April. So what is happening? It's over the period of time, one particular variable, And the second important thing is the time interval has to be equal. The time interval is 1 month. So it cannot be 1st January and for the next month it is 10th February. If for the third month it is 15th March, then it's not a time series. So two things that we have to take care of: no trend, no stochastic, nothing else, no stationarity. Those are the assumptions for the models, not for the time series. So we need to have observations over a period of time, and those intervals, time interval has to be equal. Cross sectional, we understand that for a for a point of time we have multiple variables giving the same particular thing that you are working on. For example, I'll give you a finance example. Let's say I am doing a study on automobile sector and I want to know the revenue from operations for automobile sector on 31st March 2025. I repeat myself, people who have missed can hear again. Let's say I'm doing a study on automobile sector and I have picked up 20 automobile companies. I have picked up 20 automobile companies and I'm interested in knowing the revenue from operation. Revenue from operations on 31st March 2025 for all 20 companies. If I have that on Excel, let's say I have for Hyundai, I have for Maruti, I have for Tata, I have for all the companies, 20 companies, but for one point of time. And what is that point of time in my example? It is 31st March 2025. And what is the, entity that I am studying? I am studying revenue from operations, but for multiple companies. So that is a cross-sectional data of revenue from operations on a particular point of time, that is 31st March. And then we have a beautiful data set that's called panel data, which includes both cross-sectional and time series. It includes both cross-sectional and time series. I'll give you a very simple example of that. I did a study where I tried to find out the impact of multiple variables on the oil price. Okay, multiple independent variables on the oil price. So I took, the oil stock index. I took the stock index. Let's say the main national stock index. So I took Nifty for India, and I also took interest rate of that nation. So what I did, I compared the developed nation and the developing nations. So there were three developed nations and there were three developing nations. So there were six nations, and I also took the data of last 20 years. So 20 years, six nations, and I have multiple variables. This is a unique combination of time series and cross sectional because you have multiple nations. So I I had six nations data. I had six nations data for 20 years. So it combined both time series. How? Because 20 years over a period of time and multiple, entities like six nations of all the variables that I have picked up: oil, oil stock rate, stock index, interest rates. I also took some, control variables like GDP, inflation, and interest rates. So this is a panel data. Thank you so much for your participation, guys. So but my question was different. Let's come back to the question. It was a good discussion. I was asking what are the three different types of analytics, techniques or modeling techniques we use. One is descriptive, the other one is predictive, and the third one is prescriptive. Descriptive, predictive, and prescriptive. So right now when we do regression analysis is predictive. It tries to predict, the impact of one or more than one variables on the dependent variable. Also try to predict the future values of those variables. Okay. And let's just revise regression. So it's a predictive modeling technique which investigates. We have done all these things. There's a dependent variable called a target, independent variable called a predictor. Then, these techniques are used for forecasting, for understanding the relationship. We just took example of Zomato AI campaign and its impact on customer retention. Okay. And there are many other examples. The one that I told you just now for panel data, there also I applied panel regression to understand the relationship. Okay, because my data was panel, not a time series data. Uh, so I can just skip this. Linear regression establish a relationship between dependent variable y and one or more independent variable x. Okay, we move ahead. It's going behind. Okay, G. So this is the equation that, we also teach in class, that y equals to alpha plus, beta x plus the error term. You understand what is alpha, you understand what is beta, and you understand the error term. Can somebody tell me what's the error term? Just write it on the chat box. And what is alpha? I'll just suggest you people to write it on the chat box instead of started speaking. It will be easier for all of us. I have couple of answers. Very nice. Yeah, I'll share the PPT. It's all for you guys. Error term are the unobserved term, unobserved data. Error is white noise, which cannot be predicted. Error is the leftover variable. So I think what I feel when we do, research, see, we are not mathematicians, all of us, I mean, most of us are not. I should not say all of us. Most of us are not mathematicians. We have not done MSc mathematics. So why we are using research? We are using research so that we can, we can write better research papers. We can be, a better professor in the class, and we can complete our PhDs properly. We can write a good thesis. So every time I tell my scholar that let's understand the thing in the most simplified way. Nobody is going to ask you to explain those difficult equations in detail. Okay, so you have all of you have written fabulous answers, but the most simplified answer which I see here is of Sushma Subha, who says the leftover variables influencing the dependent variables. So you remember you have done all these things in a couple of days, wherein uh, you must have done the assumptions of regression. You must have done the assumptions of regression, and one of the assumption of regression is you should not miss the important independent variables. You should not miss the important independent variables. If you do so, the model, is misrepresented. If you are trying to study something, and let's say you are trying to study the impact of multiple variables on the movement of cryptocurrency. Okay. So for why is the cryptocurrency moving? What are the factors, what are the variables impacting cryptocurrencies? So you have taken the external environmental variables. You have taken within a particular nation where you are doing this study, the internal variables, and you are trying to find out, and you miss some of the important variables. That is known as model misspecification. The higher misspecification you do in the model, more will be your error term. So error term, as Shushma answered, that it shows that reflects that you have missed, you have missed couple of uh, independent variables that are actually impacting the dependent variable. You have missed some of the predictors of the target variable. So the higher the error term shows, the more the number of predictors that you have missed. And then somebody also said that when you uh, draw the uh, forecast the regression with the actuals. So you have the actual values of the dependent variable. You let's say you take the cryptocurrency. So let's say you were doing the research till 31st December 2024. And till now, your results are out. So today, if you try to predict that, okay, you have the actual cryptocurrencies values for last 6 months now, you did it till 31st, December 2024. But from 1st January 2025 till today, July, you have the values of cryptocurrencies with you. You also have the model that you have applied on 31st December 2024. Now, when you draw and forecast, after forecasting, what you do, you merge the actual values with the forecasted values. You will see that they might not be overlapping. If the actual is equals to forecasted, that means you have really, applied a very strong model. Okay, in such a case, the error term will be very small. But if they are not overlapping these two lines, if you draw on a graph, a simple line graph you draw, and these two lines, the actual values of cryptocurrencies and the predicted values of cryptocurrencies using regression, if they are not overlapping, they are showing a difference. That means you have missed some of the independent variables, and there's a difference between the actual and the predicted, and that's the error term. There's a scope that next time you do more research, you use more of the predictive variables that you've missed in the previous research. And what is alpha as an intercept? Anyone? How to explain it in finance or economics? Again, Jagdish, I'll suggest you to be more in a more simplified manner. You're not wrong. Even Dr. Shankar is not wrong. But if I talk in real sense, what does it indicate? Very good, Chetan. So, if I good answers. So basically, the capability of the capability of the dependent variable to do something of its own is alpha. I repeat once again to make it more simple. The capacity of the dependent variable, the cryptocurrency, the capacity of its own to do something, to bring the movement in it, is alpha. Okay. So people have explained it right, that if this term where I'm focusing beta into the independent variable, if this is zero, still there is some value of alpha, that means which will so if there's some value of alpha, let's say it's 26, that means value of y is 26, because let's say b is 0. If b is 0, then the b into x will be 0, so the whole terms become 0. Still there's 26 written here, that means that's the capacity of the dependent variable to explain itself. That is alpha, this intercept that you talk about. Any doubt, anyone?
Madam, when all independent variable value is zero, that is alpha is so that what is the value of independent variable? Is right?
Sorry. Sorry, Dr. Shankar, give me a minute. My laptop has started. Guys, I'll join from my laptop. Give me 2 minutes. Firdaus, can you just start my? Can I share my stuff because right now it's showing I can't share.
Dear IT, kindly make her, co-host.
Yeah, I've joined from my laptop. My
Okay,
video
sir.
is still. Yeah, thank you so much.
Ma'am, I make you co-host and now you can share your screen.
Hi, ma'am. Are you with us?
I am so sorry. So I was just telling you that, let's not discuss that much in detail. I'll give you a very simple thing that we need to appreciate in the regression equation that, in order to have a linear regression, if there is there is a percentage change in X and due to which there is a certain percentage change in Y, every time the X has a change, there should be a constant change in the Y thing also. So that says that there is a linear relationship between X and Y. And we need to also understand this thing that for any variable, it has its own capacity to grow, to move. Okay. So that's why they say that, and sometimes it may not be, it is totally dependent on the predictors. It is totally dependent on the predictors. For example, if I am talking about, the calculation of Sensex, and I know that there are 30 odd, companies, stock prices involved in the making of Sensex, then Sensex itself has no capacity to increase. So its alpha will not be there because everything is dependent on the stock price of those, 30 companies, which will lead to the calculation of the index Sensex. I think this is more than enough to understand y equals to alpha plus beta x plus error term. And then we move ahead. So we have already done in your first 2 days that there's a simple linear regression and a multiple linear regression. Multiple has more than one predictor. And the rule of thumb that we usually tell to our scholars is that we have seen in the research papers is if you have one predictor, one independent variable, you need to have 20 cases. I mean, 20 time, limits for those time series that you're talking about. And so they say it requires at least 20 cases per independent variable. So if I have 5 independent variables, then the observations I need to have is 20 into 5. And then if somebody asks me, is it a hard and fast rule? No, it's not a hard and fast rule, but you get a better, acceptance of your research if you follow this rule to the minimum thing. Maximum can be anything, but minimum you need to have 20 cases per independent variable. So 20 observation per independent variable. Let's move ahead. So assumptions you people have already done. So I'll just go quickly with the assumptions. The first one is no hidden or missing variables. I already discussed this thing that we cannot afford to, leave the relevant explanatory variables. If you do so, you are misrepresenting the model and you will have a very large error term. And your prediction will also be poor. Linearity, I just explained 2 minutes back when some people were discussing on chat about intercepts and other things, that there should be a linear and additive relationship between dependent and independent variable. I just explained you the example. I'll give you a very simple example. So a linear relationship means if one mango is of 10 rupees, two mangoes will be of 20 rupees. So if I'm talking about the relationship between the number of mangoes and the price, I repeat once again, the number of mangoes and the price. So if one mango is of 10 rupees, two mangoes will be of 20 rupees. Three mangoes will be of 30 rupees and so on. Four mangoes will be of 40 rupees. What does this indicate? It indicates that the change in the response Y due to 1 unit change in X is constant. It should be constant for the linear relationship. Then only you say it's a multiple linear regression or it's a simple linear regression. That's the meaning of linear. And additive relationship means that the effect of X on Y is independent of other variables, which is not the case in the real life. That's why you check F statistics in regression. I repeat once again, they are saying It suggests that the effect of X on Y is independent of other variables. It does not really happen in the real life because the other variables have certain relationship with the other independent variables. So you people have also studied multicollinearity on day 1 and day 2. So multicollinearity is an extreme thing that we are talking about, where you have to drop the variables, isn't it? If you see that you have 5 independent variables x1, x2, x3, x4, x5, and x1, x2 are having the problem of multicollinearity, then you have to drop either x1 or x2. I'm not talking about such extreme cases. I'm just talking about cases where you see that there is some relationship between x1 and x2. And that's why the additive relationship is not so pure. The additive relationship is not so pure. Shankar, in multi-regression, one x variable is non-linear. What to do? Then you have to say, if you are applying a linear regression, you have to remove it. Or then there are places where you can turn, you know, that's what you say nowadays, you can tweak. So you turn the time series into a linear time series. There are ways to do that. Have any idea number of independent variables have to be? No, see, uh, picking up independent variables, Minju, totally depends on, no. It totally depends on the literature. It totally depends on the literature. So that's why they say, some of my scholars says why to do, literature study, why we need to read. It is very, very important because you will not have the chance of missing any of the important independent variables. Okay. See, I don't say 5 or 4, but usually, Ananto, what I feel is the best thing is when you're doing a multiple regression, you need to go through the literature and you need to study how many independent variables have been impacting the dependent variable in different, time zones and in different, geographical areas. So let's say you're doing a study in China, and then you come across a study in Australia where a particular independent variable was impacting the dependent variable. So you do pick up that for China also. So how do I come to know about that? I read the literature, I read the good consultancy reports, and I come to know, okay, these are the variables that also impact they might impact the dependent variable. So number, I am really against giving a exact number. There is no hard and fast rule. But Ananta, if you want to take 5 for panel data, I'll not say it's wrong, but I won't say it's the best way of choosing. Okay, so let's check now. Where was I? We were talking about addictive. So how do we find out? You people must have already done it. To find out the the linear relationship, you simply draw the scatter plot and you check whether there most of the items are coming on the straight line. So you basically what you do, you draw a graph, the scatter graph, and then you have this line. It has to be straight. Please excuse my drawing using a whiteboard. And then you try that most of the the dots are near the straight line. Then you say that yes, it is a there's a linear relationship. Statistically we check like this, one of the ways. No multicollinearity. Are you people aware of multicollinearity and how do we remove it? Can anybody write on the chat box? How do we remove the problem of multicollinearity on the data set? You know what is multicollinearity? When there are more than, more than there are two or more than two independent variables that are, highly correlated. So they, you say that there's a problem of multicollinearity. And when two independent variables are correlated, why do we say that they are multicollinear? That which particular independent variable is causing the effect? Is it x1 or x2? Because x1 and x2 are highly correlated. So the model becomes, confused that is it x1 that is leading y or is it x2 leading y? That's why you say that multicollinearity is a problem. So I see a couple of answers. Uh, Statement, drop one variable by dropping the variable, one method excluding the variables. Okay. And how do you drop the variables, guys? How do you decide which variable to be dropped? Okay, let's check it. So I've taken a very simple example, where I wanted to explain you why multicollinearity is a problem in your research. I've taken an example of house prices. That there are certain, house price is a dependent variable, and these couple of independent variables are thought of, chalking down for you: number of bedrooms, number of bathrooms, total square feet area, location rating, and other things. Now, do you see there are any two variables where you see there will be a problem of multicollinearity? Any two variables, independent variables, where you see the problem of multicollinearity? So, somebody has written something, let's check it. We study the impact of area, temperature, and rainfall on yield as we take actual value of temperature on some survey use temperature value into. We'll do these at the end, Shankar. Right now, we are in the middle of something by seeing the correlation metrics, highly correlated variables drop. No. Tell me, Kiran, there are, you have taken, you have taken couple of variables. Sabhya is right. Ananta is also right. Bedrooms, bathrooms, no. I'll tell you. So the two variables that are related are the number of. Trying to pick up the pen here. So the two variables are number of bedrooms and the total square feet area. So we need to appreciate this fact that if the area is more, we can come out with more rooms. Okay, if the area is more, we'll come out with more rooms. So what happens when you calculate the correlation between number of bedrooms and total square feet area, the correlation comes out to be very high. Okay, so somebody was answering that you drop one of them and you drop the one which has a higher correlation. But the correlation that you calculate between the correlation you calculate, you do not use the dependent variable there, guys. I want to repeat this. When you calculate the correlation, you do not include the dependent variable. What is the dependent variable here? The dependent variable is house prices. So when I'll be calculating correlation to understand the problem of multicollinearity, I will not use house prices as the time series. I'll use these four time series. I hope you get it. So when I use these 4 time series, I see that, there is high correlation between number of bedrooms and total square feet area. How do I know? Shall I drop number of bedrooms or shall I drop total square feet area? Which time series to be dropped? How do I know that? Anyone will like to answer on the chat box? So what I do, I run a simple regression, guys. I run a simple. Am I audible? Akanksha, am I audible?
Yes, ma'am, you are clearly audible.
Okay, thank you, thank you. So
Yeah,
I
ma'am.
run a simple regression and I check that what is the p-value of number of, so what regression do I run? I run a regression wherein, I have house prices as the dependent variable y equals to alpha plus, first dependent variable as number of bedrooms, second dependent variables is number of bathrooms, third is total square feet, and fourth is location rating. So I take these 4 and I run the regression, and then I check what is the p-value of all the dependent variables, and which p-value, which 2 dependent variables I have to check, number of bedrooms and total square feet area, and the p-value has to be higher to drop that variable. Why it has to be higher? The more higher the p-value, the less significant it is. Okay, I'll just show you. So these are the steps that we follow. I hope you have done on day 2 or day 1. Identify higher correlated variables. So how you run a correlation analysis on all independent variables. So you see that we take only independent variables. Okay. And then if the correlation is between any two independent variables very high, let's say more than 0.9, then it suggests there's a problem of multicollinearity. So I've taken an example for you. People will also do on e-views. X3 and X4 as a correlation of 0.95 shows a problem of multicollinearity. What we need to do now, we need to either drop X3 or X4. Which one to drop? The second step is you use the p-values to decide which variable to. How do we get the p-values? We run the regression on e-views. Okay, we run the regression through quick estimate equation. In equation, we write the dependent variable, C independent variable 1, 2, 3, and we click OK. We get the results. I'll show you on e-views. Okay, I'm just telling you. So there we see that the coefficient values are there, the p-values are there. Now we know that the p-values has to the null. What is the null hypothesis in a regression? There is the independent variable is not significantly impacting the dependent variable. The independent variable is not significantly impacting the dependent variable. So how do you choose that which is significantly impacting? Something less than 0.05. Something less than 0.05 is having a significant impact. So higher the p-value, lower is the significance. So what you do? You check the p-value of x3, you check the p-value of x4. I've given you the example. X3 p-value is 0.06 and x4 p-value is 0.30. So which one do you drop? You drop x4 because it is less significant than x3. Any doubt till here? Anyone? Okay, I have 3 messages here. Area, number of bedrooms. No, ma'am. Okay. Give me 1 minute to drink a glass of water. I'll be back. Akanksha, 1 minute, okay?
Yeah, sure, ma'am. In the meanwhile, participants, if you have any query, you can just post your questions in the chat box.
Yeah, I'm back, Akanksha. Sorry, I'll just share the PPT.
Yeah. Ma'am, there is one question in the chat box.
I'll just check it.
Yeah,
Let me
sure.
just share the PPT. Hmm. Jagdish, how to calculate p-value? The results give you on e-views. Uh, I hope I hope you have done it on e-views on day 1 and day 2. That's what the organizers told me. Otherwise, time permit, I'll show you how to do it on e-views. Okay, so let's move ahead. I was telling you how to remove the multicolority problem. I showed you 2 steps which are given in front of you. You'll just check the regression on e-views, and then I'll show you how to follow those steps on e-views so that things are more clear. But you cannot take any 2 variables in your research paper where the correlation. So the first step you do while applying regression is you apply correlation among the independent variables. So you apply regression among the independent variables, and then you check whether the correlation is above 0.9. Sometimes I give leverage to my scholars where they use, let's say one of my scholar was doing a study on multiple cryptocurrencies. So he took around 10 to 12 top cryptocurrencies, and he told me, ma'am, some of the cryptocurrencies have a very high correlation, and it's ranging from 0.85 to 0.9798. So I told him, okay, we can take a leverage of picking up those variables which have the correlation of around even 0.92 or 93, but anything above 0.95 you should drop those variables. Okay, so we have gone through it. Then these are some of the other assumptions that we check. No autocorrelation in the residuals. You must have done this. And this is desirable that there is no serial correlation or autocorrelation in the residuals. And how do we check it? We check it once we apply the regression. Then no heteroscedasticity. We also check this in the residuals, that the error term, the error terms that you have, they must have constant variance. That means they can move, there can be fluctuations, but the fluctuations over a period of time should be constant. The third thing, these are also known as residual diagnostics. So 3 residual diagnostics are among the assumptions. One is no serial correlation. The other one is no heteroscedasticity. Third is normal residual. So your residuals, form the normal distribution curve. You check the Jar-Kabira p values, and they have to be. Ma'am, please go to the slide. You can't see the screen. I'm so sorry. Isn't the screen visible?
Ma'am, the screen is visible, but the slide is the first one only. You need your introductory one, like where the introduction is.
Achha, it's not changing. Today, it's a tough day for my laptop. I know what's wrong.
We all understand, ma'am. It's okay. It's okay. You just take your time.
I'll share again. Sushma, is it visible now? Is it changing? I mean,
Yes, ma'am. Yes, ma'am. Normal residual. The slide is showing normal residual.
okay. So I'll show you from where, I was just talking about. So we were discussing the assumptions of regression, and a couple of assumptions that I discussed with you in last 5 minutes. There should be no autocorrelation, which is also known as serial correlation, the residuals. This we do under regression. Check that there is homoscedasticity. That means in the residuals, that means there should be the error terms must have a constant variance. The simplified meaning of this is that there can be fluctuations in the error terms. I'm not saying the error term will be fixed. There can be fluctuation, but the fluctuations over a period of time needs to be constant. And the third one is normal residuals. This we check using a Jarka-Bira normal distribution test. I hope you people have done this also. Now, these are the steps that we apply in regression. You go to quick, you go to estimate equation, you write your equation. The least square method is already selected, so you just click on OK, and then you get your results. Now, the results that we focus on. So we check the coefficients, which one is positive, which one is negative. So while writing the results, if there's a negative correlation, you can see that here, the impact of market campaign, salary and travel expenses have been checked on the sales figures of the company. So we see that the salary has a negative impact on the sales. So if you're giving a very high amount of, the total, so it was not separate salaries of different employees. What we did, we picked up the total amount of salary dispersed by the company, so which is given in the balance in the P&L account in employee under employee benefit expenses. So what we did, we picked up employee benefit expenses, and we saw that the result shows that there's a negative relationship between sales and salary. So we need to write while explaining these results, we need to write things which are, let's say sales is if the market campaign is increasing, the sales are increasing. If the travel expenses are increasing, the sales are increasing. But if the salaries are increasing, the sales are decreasing. So this is the way you need to explain. Then the p-value of independent variables. So the first one, market campaign, the p-value is 0.6363, which is insignificant. We all have done it already. So I'll be a bit quick. If you have a doubt, you can just write it. Oh, I can see 6 messages. Okay, that's about the slides. So we understand that for market campaign, the p-value is insignificant. For salary, the p-value is significant. For travel expenses, again, the p-value is significant because it is less than 0.05. So second thing we check is p-value of independent variable. And what is desirable? It is desirable that maximum independent variables that you have used in the study to explain the dependent variable, maximum should be significantly impacting the dependent variable. Maximum independent variable should be significantly impacting the dependent variable. Then is the R squared value. Which one do you prefer, guys? R squared or adjusted R squared? And what is the difference? R squared or adjusted R squared? So Kavita said adjusted R square. And what does it signify, Kavita? Okay. Ananta also said adjusted. Sushma also said adjusted. What does it signify? I mean, what does it mean, adjusted R square? Adjusted R square means the calculation has only taken the significant independent variable. The adjusted R square means it has dropped insignificant independent variables like market campaign and travel expenses. So better thing to write in the research paper is adjusted R square instead of R square. Then is F statistics, where F statistics tells you that if I take all the independent variables together, whether the model is strong. So it shows that if all the variables are taken, okay, let's talk about the value of adjusted R square. It is 22.72%. That means 22.72% change in the dependent variable is because of the significant independent variable. I repeat my sentence, I go slow. 22.72% change in the dependent variable sales is because of the significant independent variable salary. Is it okay, guys? And F statistics probability value is significant, which indicates that the model is a strong model, but I don't feel it's a strong model. So we cannot just judge by one thing, seeing the F statistics value. So, the null hypothesis of F statistics says that this is your beta 1 coefficient, this is your beta 2 salary 1 minus 0.53, this is your beta 3, that is travel expenses. It says beta 1 equals to beta 2 equals to beta 3 equals to 0. That means they are, they are not significantly impact together. Together, they're not significantly impacting the sales figure, but as the F statistics probability value is less than 5%, that means they are significantly together, they're significantly impacting sales. I hope you have understood the value of adjusted R square. How do we write for adjusted R square? So desirable output which you prefer for, this is desirable, not necessary that your research will give this. R square to be higher, desirable is 60% and above. More and more independent variables to be significant, F statistics to be significant. You also need to see that the residuals are not having autocorrelation or serial correlation. The residuals are not heteroscedastic, they are homoscedastic, and the residuals are normally distributed. Usually it is tough to have the last assumption right, that the residuals are normally distributed. So these are the desirable output, from a regression that you must have learned in last 3 days. And in order to apply regression, we follow any model for time series. We need to remember this thing. I hope most of you know this thing, that for any model that we need to apply on time series data set, the time series have to be stationary. All the time series have to be stationary. Usually, what I have seen in past 20 years, that financial time series are mostly non-stationary. So you must have learned yesterday how to, turn a non-stationary time series to a stationary time series. It is, by calculating the first difference. And in, financial data sets, it's very easy. You calculate the log. So when you calculate the log, you calculate the first difference. Okay, because what is and when you calculate the, and it's, if it's a, a data of returns, you can calculate log returns. So usually what I do on financial data sets, I work on log returns, which is log A minus log B. So what is log return? It is log A, that means log of today's price minus log of previous day price. Whether it is, the exchange rates, whether it is the gold prices, whether it is cryptocurrencies, whether it is bond prices, whether it is stock prices. What I do, and more, I have, it's not me who is doing it. I follow the, top research papers. They work on the log returns data. Or you can also, do the calculations on HPR, historical period return. I'll explain, Ananta, I'll explain F statistics. Is it overall changes by R square? I didn't get, Jagdish, I didn't get your question, sorry. Is it overall changes by R square? Sorry, can you explain it, write it more, in an explanatory way what you're trying to ask?
Madam, I asking about R square.
Yeah.
Some coefficient are less, very less. R square represents the overall value or only one value, only one variable value.
I'll tell you. So, Jagdish, when we take normal R square, it includes all the variables. Okay, and it actually tells you, for the example I took, it tells you that what is the percentage change in sales due to the independent variable. So let's say I'll go to the results. Just a second. So if you can see here, Jagdish, the dependent variable is sales, and there are three independent variables. R square is 24%. 0.2429 is 24.29%. So I rounded off 24%. So it is actually saying that 24% change in the sales will be caused by all these three changes in all these three variables: market, campaign, salary, and travel expenses. Adjusted R square says that let's leave the insignificant variables like market, campaign, and travel expenses, because their p value is insignificant. They are not significantly impacting the sales. So let's take only that variable which is significantly impacting sales, which is only salary in my example. So adjusted R square gives you a more precise answer that 22% change in sales is because of the significant independent variable, which is salary in my case.
Okay, madam.
Yeah. And Ananta, you asked about F statistics. Pen is not working. I wanted to show you what it says. Let me try with my pen. It says that beta 1 equals to beta 2 equals to beta 3 equals to 0. This is your null hypothesis. Okay, this is your null hypothesis. So what happens when these figures become 0? When these figures become 0, that means they are together not significantly impacting sales. They're not significantly impacting sales. That is a null hypothesis. But what is the p value, Ananta? It is 0.000, which is less than 5%. So that means my null hypothesis cannot be accepted. My null hypothesis is accepted when it is greater than 5%. So that means what is accepted? The alternate hypothesis. What is my alternate hypothesis? That they are significantly impacting together, not individually. Individually, I've seen they're not significantly, but together as a model, they are significantly impacting sales. So it's a good model. That's how you interpret F statistics probability value. Is it okay, Ananta? So these are my desirable outputs. Now there's one more question which is asked by Kiran, why we take log of variables. Okay, okay, I'll tell you why we take log of variables. See, for time series, you people have to always remember that your data, has to be normally distributed, which is desirable. Usually, your data is not normally distributed. Okay, financial data is not normally distributed. It's not a bell-shaped curve. So, but what do you try? You try that the range is not very high. Ranges, the maximum minus the minimum is not very high. And you also try that, your, I mean, in a normal distribution, it's a very unique situation where the mean equals to median equals to mode equals to 0. But you try that your, mean is not, mean, median, mode are not very different. But it's not possible. In financial data, it's not possible. But the more important assumption in time series is that, stationarity. That means over a period of time, let's say I've taken a period of 5 years and I've taken daily stock prices. So over a period of time, they say if we calculate the mean and standard deviation and other statistical measures, descriptive measures, they should be constant over the time. Okay. Again, the sad part is that if you take, let's say you take the, you take green bonds. Okay, and you check the stationarity. Augmented Dickey-Fuller test, they must have told you yesterday. You apply ADF, you check the stationarity, it is not stationary. Then you cannot start with any model in time series. You cannot start with any model in time series. You have to first convert it into stationary. So the, converting it into stationary, you have to take the first difference. The first difference means the series. If this is your series X, then you calculate the X minus 1. You calculate the difference between this and this term, this and this term, this and this term. This is the first difference. Okay. So how do you calculate it in finance? It's very simple. You calculate the log returns. Let's say I've taken the cryptocurrencies. So I have the series in front of me. What is the formula for log return that we teach our students? It is log of today's price minus log of previous day's price. Okay, that's what we teach them, which is equal to log of today's price upon previous day price. So you calculate this thing. So when you're calculating log returns, which is log of today's price minus log of previous day price, what are you calculating actually? You're calculating the first difference there. Because first difference means the series itself, and what is the first difference? The first difference is the subtraction of the series with its next day. The next day to its next to next day. The next to next day to its next to next to next day. So that is the first difference that we calculate. And log returns solves the purpose because log return is log of today price minus log of previous day price. This is the first difference. Then once you do that, once you calculate the log returns, you have to check the stationarity again. You have to check the stationarity again using ADF. Then you will see that the stationarity, non-stationarity problem has vanished. Unit root problem has vanished and your data is stationary. Is it okay? Is your doubt clear? Somebody asked it. I'm not going through the residuals here. I was told that you have already done. No, see, Sujata, wherever you do, your results will be same. These are just softwares and doing the same thing backstage. So you don't need to worry about that. Yes, Akhil, we do that to remove. That is just log transformation. So Akhil, you are right. To even to reduce the problem of normality, Akhil. Your data is not normal. To reduce the variance, you calculate log. What does log, what is the purpose of log? To reduce the variance. So heteroscedasticity also means that there's variance, which is not constant. So you can use log. This is a step ahead. You are just not calculating log, you are calculating log returns. Okay, like HPR, holding period return. You are calculating log returns. Akhil, I hope I have answered your question. Okay, shall I move ahead, guys? We are still revising what you people have already done in last 3 days. I need to be quick. So I'll skip the residual diagnostics. These are the steps. Once you have the result out, which is known as your estimated output, you go to views. In views, you go to residual diagnostics. There are many residual diagnostics given to you. We check the three, bare minimum one, which the editors expect you to do: serial correlation, heteroscedastic behavior, and histogram normality. And then is the forecasting in regression, which I'll show you. The forecasting in regression. Shall we open our e-views? That's from my side on PPT, but let's open e-views and work on it. So Jata, clustering volatility is in cards. So once we complete regression, I'll tell you what is clustering volatility. Okay. I'll just move to e-views. Can you people open e-views? Akanksha, do they have that file that I've shared with them?
Yes, ma'am. Firdousa has already shared those files.
Okay. Can you see the e-view screen, guys?
Yes, ma'am, it's visible.
Perfect. So I think you first open regression FDP. We quickly check the problem of multicolority, how to solve it. And then we also check regression results. Quickly, I'll show you the steps because I think you people have done it on day 1, day 2. And then we also like to see the forecasting thing, and then we move to Garch model. So I'll not open the sheet. Okay, let me open this sheet. You can also open sheet 1. Do you understand this thing? Linked imported series and alpha objects to external sources. It tells you that if you say yes, then any change you do it here on the variables figures will be done in your Excel sheet also. And if you say no, then your master sheet will be intact. The Excel sheet won't get changed. Okay, shall I show you these steps? So what I can do is I have GDP data, and see, I already have a constant here, but the constant will be nil because I have not applied regression. So econometrics basically works, its bread and butter is regression. So it's based on regression. So you can see there are constant values 0 because we have not regressed anything. And even you have reset, there will be no values in reset because we, again, the same reason, we have not regressed anything. Okay. So what I do, I go to quick, I go to estimate equation, and I write my equation. Let me use log GDP as the dependent variable. No, I've used GDP. I'll use log GDP. Then C, then I use, let's say, log of interest rates, inflation, log of interest rates. I'm seeing the impact of interest rates, inflation, and let me take something more. I take, let's say, stock price. And it's already a least square, ordinary least square under multiple linear regression. So I press OK. So these are my results. You people can see the results in front of you. Okay. So my dependent variable is log GDP. Then I see the coefficient. Interest rate is negatively related to GDP. And I see inflation is log inflation. So inflation is not significantly impacting because I see the value as 0.33, which is more than 0.05, so not significantly impacting. Then stock also I see 0.66, which is more than 0.05, so not significantly impacting. Only interest rates are impacting GDP because the value is 0.00, which is less than 0.05. I check my adjusted R square, which is 21%. It's a very less, so according to the, if I say the kind of model it is, according to the significance of variable, it's not a good model. Out of three variables, independent variables, only one is significant. So no, not a very big deal. Adjusted R square, which desirable is 60%, it is just 21%. So 21% change in GDP is explained by interest rates. So not very good. Probability is significant that altogether they are, significantly impacting, but the explanation is only 21%. So this is one thing. Then I wanted to show you the forecast. So we go to forecast. Now, the forecast name for the, the estimated output will be recorded, and you can change the name, but I keep it at GDPF. F means forecasted, and you don't need to change anything. You press OK. So you see, two series, log GDP here and log GDP forecast. I open both the things. So I open both the things together, open as group, and then I go to view and I go to graph and I make a simple graph, single graph, okay, and see the values of forecasted versus actual. So the actual values are indicated by the blue line. The forecasted values are indicated by the the red lines. And, the years 2007 month 2 to 2016 month 12, I can see that there's a, big difference between the forecasted and the actual from the year 2007 to 2011, mid of 2011. Then I can say that, the model started predicting the values to a certain extent, where the difference between the actual and the forecasted reduced. But if I see here, that's why the prediction is very, the R squared value was very poor. It was just 20 in 21 or 22%. Because see, the actual is this 1.9 and the forecasted is this 2 point something. So just a revision of what you have already done in last 3 days. Shall we move to the Garch model? Or you have any doubts? You have done it with me or not? Or I was fast? Will you like me to repeat it? I can repeat it for you. Okay. Let me repeat it for people who have not done it. It just takes a minute. So, if you want to even do correlation in the, I'll just go with the starting when you check multicollinearity as an assumption. So you want to do check multicollinearity, you open the, time series together for which you have to do it. So log GDP, you'll not take because it is the dependent variable. You take only independent variable. I'm not supposed to take. So you open them as group, and once it is open, you can go to view and you can go to covariance analysis. I hope this is okay. You people know how to open it in a group. All of you know how to open the time series in a group, or shall I show you? Okay, you people know then. So once you open them in a group, you go to view and you go to covariance analysis. You click on it, and here you select correlation instead of covariance. You can even check the probability values. So I clicked on 2 because I need correlation with its probability values. You click, you don't change anything, you click on OK. So you get the correlation. I check it. The correlation between interest rates and inflation is moderate, oil and inflation is negative, low, and oil stock and inflation is very low. So there is no problem of multicollarity. In case there was a problem, let's say this 0.72 was instead of 0.72, it was 0.92. So that means I had a problem of multicollarity between interest rates and inflation. Okay. So what I do, I simply run the regression. So I go to quick, I go to estimate equation, I write the dependent variable log of GDP constants. For constant, I write C, then log of, let's say I take inflation, log of, let's say I take interest rates. I take 2 this time. I press OK. I don't change anything. I press OK. These are my results. Interest rate is significant and inflation is insignificant. Explanatory percentage is 22 and statistics is strong. And then I have to forecast. So I go to this tab called forecast. I click on that. It's asking you what you want to name. It's asking you the time period. You can change the time period also, guys. You want to take some small time period, you can do that. And then you press OK. Then you close this or you just move it. Now you have log GDPF and log F. You can open them together, make a graph to check how much overlapping is there. So you go to view, you go to graph. This is the simplest way of explaining, and here it is. So this was all about regression. Any doubt till here, anyone? Now I go to Raj. Any doubt, anyone? Let's go to a volatility model then. Okay, let me share the screen. I do it as full screen. My screen visible, Akanksha, the Gauge modeling?
Yes, ma'am, it's visible. Gauge modeling.
Moving?
Yeah, it's perfect.
So let's see how much we can understand, how much time permits. I know your time is up, but as I started late, so I'll be taking your 20 more minutes. I know you people are tired, but let's understand the Gauge modeling today. So these are the things. I'll just skip the content part. Okay, what we are covering. Let's introduce the Gauge model, which is generalized autoregressive conditional heteroscedasticity model, popularly used for volatility analysis. It is popularly used for volatility analysis. Now, what do I mean by volatility analysis? I was interested in knowing that, uh, how is the volatility of BRICS nation, connected. Connected means I wanted to know that the stock markets of all these nations, how they are connected as far as volatility is concerned. So volatility means there is deviation in the stock returns, or I should not say stock returns, any returns. Okay, so if I want to do such studies, I will not use regression because regression works on mean values. I will use Gauge model because they work on variance values. Variance means standard deviation values. Okay, and volatility means you're studying the variance. Okay, so one of the famous model that we do is the Gauge model, which is generalized autoregressive conditional heteroscedasticity model. We need to understand all these things. It is based on generated from the Arch model. Now let's understand the Arch model where one term is autoregressive. I think yesterday you guys have done something related to autoregressive, if I'm not wrong. What is autoregressive? Can you write it on the chat box? Autoregressive? No one? Okay, somebody has written it. I can feel that you people are tired. Very nice, Ayatan. The current values are affected by the past values. That's what I think you have done Arima yesterday. The dependent value is a function of its lagged values. Very nice. Kashmiri does. That's the again one of the right answers. That auto-regressive means you have regressed the series, time series. Let's say you have taken Nifty. So you have regressed the Nifty with its own lagged values, Nifty -1. That means if this is 2500, this is 2550, this is 2570, this is 2590, so on and on. So what you have done, you have and this is, let's say, this is 30th, this is 29th of January, this is 28th, this is 27th, and so on. You have regressed it with 29th, 2550. You have regressed it 2570. You have regressed with 2590. So what you have done, you have calculated the regression R between this series and this series. Nifty and Nifty -1, that is lag 1. It can be lag 2 also. So you do not start with 2550. If it is lag 2, you will write 2570 here, 2590 here. So it will be auto regression with lag 2 lags. Is it okay, everyone? We understand what is auto regressive. You regress the series with its own past values. Okay, conditional heteroscedasticity, I'll explain you with somebody asked me clustering, variance. I'll explain you with that. Okay, this is my, so today we'll be doing a very simple model, GARDS 1-1 model. So Gauge 1-1 model, whenever you do Gauge model, you have two equations. One is the mean equation, the other one is the variance equation. And we have to focus on the variance equation in order to study the impact of volatility of one independent variable on the volatility of dependent variable. So what we are studying right now, we are studying not the mean thing, but we are studying the variance thing, which is called volatility. So when I study GARCH, I have two kind of results. One is GARCH shows that what is the impact of volatility of the past value of the time series on its today's volatility. Do I understand this? I repeat once again. So we are more concerned about the variance equation. What does variance equation studies? Because it's a GARCH model and GARCH has autoregressive. Autoregressive means what result you will get? You will get what is the impact of volatility. Let's say it's Nifty. So I will be able to understand what is the, and I am applying 1-1 model. 1-1 model means 1 lag period of GARCH term and 1 lag period of ARCH term. Now what is GARCH? GARCH studies the impact of volatility of the previous day on the volatility of the present day. GARCH term studies cluttered. Okay, I repeat once again. You need to understand what is GARCH 1-1 model. So in GARCH 1-1 model, we are only focusing on lag 1. You can have more lags, and there is a lag selection criteria also, where you can select the lags. We are not doing it today, of course. So we have assumed that we are doing GARCH 1-1 model. 1-1 model means 1 lag of GARCH term and 1 lag of ARCH term. Now we need to understand what is GARCH and ARCH term. Okay. So what is GARCH and ARCH term? GARCH term means that if I have taken the series Nifty, I am interested in knowing what is the impact of volatility of yesterday, because it's one day, on the volatility of today. On the volatility of today, guys. So you have to appreciate that we are only talking about volatility, not returns of today. In case of GARCH, so this is the GARCH term. And ARCH term means what is the impact of Nifty return information, and that to what? Yesterday's return Nifty, yesterday's return information, how much return it made. Okay, information on the volatility of today. This is the ARCH term. So I've taken an example where you see there is a dependent variable which is BBR. BBR is BSC bond return, and this is BSR, which is BSC stock return, that is Sensex. Okay. So let's check it out. This is the variance equation that you see in the result. I have simply copied it. This is what we need. So this is the mean equation you write. This is the mean equation, guys. Simple mean equation, that the way you have learned. Dependent variable equals to constant plus independent variable plus error term. Okay. So The variance equation is volatility of today. HT is volatility of today equals to constant plus volatility of yesterday. So what is this? This is the Garch term, HT minus 1. What is HT minus 1? It is the previous day volatility, the lag 1 day volatility. And what is E square T minus 1, which is residual square T minus 1? This is the arch term. What is this? This is the previous day bond return information about the volatility. This is the previous day bonds return information about the volatility. Okay. Plus we had Bombay Stock Exchange stock return also. Remember in the equation? This is missing here. And then there are other two external variables, which is IBR and PBR, Indonesia bond return and Pakistan bond return. These are the other exogenous variables. So two things we need to understand. One is HT minus 1, one is E square T minus 1. HT minus 1 is the Garch term. E square T minus 1 is the arch term. And what is the Garch term? The Garch term is the previous day volatility of the same thing. That means in my case, the previous day volatility of the Bombay Stock Exchange bond return. See, this was my model, Bombay Stock Exchange bond return. So what is HT minus 1? The yesterday's volatility of Bombay Stock Exchange bond return. And what is E square T minus 1? It is the yesterday's bond return information about volatility. It is the information that impacts the volatility. That is the arch term. Any doubt, please ask. No doubt means people are not listening.
Ma'am, it means you're explaining very well.
Okay. Okay, let's take the assumption somebody asked clustering variance, and I'll explain you with conditional heteroscedasticity. One of the important assumption after stationarity, you need to check whether your series are stationary or not. If not stationary, you cannot apply the Garch model like any other time series model. So what you can do is you can simply calculate log returns and you can check using ADF test your series will be stationary. Once you do that, you check the conditional heteroscedasticity. Let's understand what is conditional heteroscedasticity. So, basically what conditional heteroscedasticity says that there is variance. Heteroscedasticity says variance is not constant. We all understand that. We have done it in regression. Homoscedasticity says that there is variance, but variance is constant over a time period. Heteroscedasticity says the variance is not constant. Okay, so in this graph, if you see, in this particular graph, you see, sometimes this is a variance graph. So sometimes the variance is still here and then the variance increases and it is high and then the variance decreases. Okay. One thing, so there is heteroscedasticity available. Conditional heteroscedasticity, which is related to clustering variance. Clustering variance means period of low volatility. This is low volatility, guys. So period of low volatility is followed by period of low volatility. So if I say from period 180, if this is 180 till 270, I see a period of low volatility. So today's volatility is impacted by previous day volatility. One thing is proved here, because yesterday it was low, today also it is low. But why it is heteroscedastic? Because after a certain period of time, it is increasing, it is going very high. So heteroscedastic behavior is there because heteroscedastic says that you do not have no constant variance. So I can see in the graph that the variance is not constant. Sometimes it is low, sometimes it is high. Conditional means there's a clustering. There's a condition attached to it. So what condition? From, let's say, period 0 to period, let's say this is 80. So period 0 to period 80, I see low volatility followed by low volatility. And from period 80 to period 180, I see high volatility followed by period of. This is known as clustering variance. And this is known as conditional heteroscedasticity, which needs to be there in your time series data so that you can apply the Garch model and get beautiful results out of it. Okay. So we see from figure 1.1 that there's a prolonged period of low volatility from day 1 to day 85, and also there exists a prolonged period of high volatility from day 90 to day 180. I already explained you. In other words, period of high volatilities are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility. This is known as volatility clustering. This suggests that residuals is conditionally heteroscedastic, and it can be represented by using a Garch or Arch model. Somebody asked me this thing. I hope your doubt is clear. I'll be telling you how you plot this graph, don't worry. You have to check this. This is one of the assumptions. So here you go. Alliance, you have the answer. First check the assumption. To check the assumption, what we do, we go to estimate equation. You write same way you write in regression. You write the dependent variable, you write the independent variable, and you press OK. Then you go to residuals. I'll show you where you go. Maybe it's in the next slide I have shown. See, you can see where is the mouse. So you go to resids. Once you go to resids, you don't need to read anything here. The graph, the plot will be there in front of you. Again, the plot shows that there is low volatility period followed by low, and high volatility period followed by high. Is it okay? Any doubt here, guys? Anyone? I can repeat. Okay, so now we apply the Garch model. I hope you have understood the variance. So it is important to understand the variance equation. Why so? Anyone? Why it is important to understand the variance equation in Garch model? Because you cannot complete your research methodology part unless and until you write the equation for your research paper. So you have to write your equation. So you need to understand the parts of the equation here. Okay. So we need to understand which is the Garch term and which is the Arch term. So on the, once you have made the plot, you go to estimate. Yes, we'll be doing it, Alliance. Have patience. I'll definitely do it on eViews. Don't worry. Give me a chance to complete the slides and then I go to eViews and show you. Is it okay, Alliance? So on the receipt plot, output that you have in front of you, you go to estimate and estimate window. The dependent and independent variables are already filled by you. Select the arch model in the method box. We usually select the already selected arch model. We do not change anything. We fill the variance regressors. We press OK. You get the equation in the output. No, you just need to There may be, but usually what I have seen in research papers, Sujata, you make the recit plot. That's the best way of visualizing clustering volatility. So I have always made a recit plot for clustering. You have to do that. I mean, that is compulsory. If there are any other tests, you can search it, but I usually stop there. If I can see clustering volatility on the plot, then that proves that I can apply GARCH. That is acceptable by the editors. Okay. So see, this is the way you go to equation estimates. You pick up the arch method, and then here you fill this is already filled, you don't need to do it, but you can write your other independent variables in the variance regressors. You need to appreciate this thing that the whole arch is dependent on variance, not the means, because you're calculating volatility, and we all know as finance and economics people that volatility is calculated using the statistical tool variance. So you see the variance regressor here, and then these are your results. I'll just show you how to read the results, and then I'll show you on eViews also. So the dependent variable is uh, BSC bond return, and the independent variable is BSC stock return. And you see the GARCH equation, which is automatically made by you by the uh, sorry by the eViews output. And there are a couple of methods of calculating arch. You can take any method, the results will be same. This is the normal distribution method, ML arch. There are other students T and other methods, you can use that. The results will be same. So you see the guard term. Let's understand the guard term here that you see. So this is what is guard. This is today's volatility. You're trying to understand today's volatility of BBR, BSC bond return. Okay, guys. And C3 is constant. C4 recid, my square is your arch term. This is your arch term. Remember, I showed you E square. This is recid is E. So E square minus 1. This is your arch term. And this indicates easily C5 you have to refer for your guards term. It is naming that, and these are your independent exogenous variables. So in this, I see that the volatility of the BSC stock risk return is significantly impacting the volatility of BSC bond return. Do you appreciate this fact that the volatility of BSC stock return is significantly impacting the volatility? So everything is volatility, guys, not the returns. It is volatility. The other thing that we see is the arch term. What is the arch term? Previous day return information. So previous day's return information is significantly impacting the today's volatility of BSC bond return. I repeat once again, previous day return information is significantly impacting today's volatility. Previous day volatility is also impacting today's volatility. The volatility that occurred in the last day is impacting today's. So if the market was volatile yesterday, it will be volatile today also. And for IBR, Indonesia bond return and Pakistan bond return, Indonesia bond return significantly, volatility of Indonesia bond return is significantly impacting the volatility of BSC bond return, but the volatility of Pakistan bond return is not impacting the volatility of BSC bond return or Indian bond return. Can you understand the results that I've explained? Any doubt in this, guys? I have two messages. I don't know, Alliance. I usually don't do it. If you want to check it and write this way in the research paper, you can go ahead. Okay, the interpretation I've already given you. So without wasting time, let's go to the e-view stuff.
Hello.
It is my e-views. There it is. Is my e-views visible, everyone?
Hello.
Yes.
Ma'am, can you show the result once again?
The results. Okay, here we go again.
This is the result, madam.
Want to ask something?
Yes, madam. Madam, what is the coefficient value BSR? This one and GARC 0.04. One. What is the how to understand?
See, what is the coefficient value?
Yeah, the same interpretation for the regression analysis.
For the interpretation of the regression, Shankar, you do not write the values of coefficient anywhere. For that matter, Shankar, even in regression, if you are writing your thesis or your research paper, you do not write the values of coefficient anywhere except your equation. So in your equation, instead of C5, C6, you can put the values. But usually you do not, Shankar, you do not put the values. While explaining the results, it's more important for you to explain that which are the variables which are significantly, whose volatility is significantly impacting the volatility of your dependent variable. What is the arch term significant? Is the guards term significant? So these are the things that you focus on while writing the results, not the coefficient, Shankar.
Okay, ma'am.
Yeah. Alliance, what are you asking? The mean equation you're asking. So the mean equation result says that the the return of the BSR, which is BSC stock return, is significantly impacting the BBR volatility. So this part that you're asking, I think you're asking this part, in which we have the constant and we have the BSR, which is BSC stock return, is significantly impacting the BSC bond return. So this talks about the returns and this talks about the volatility. Can I move ahead, guys? Can I go to e-views now? Okay, let's move ahead. This is my e-views. Let me open something. You guys also open the file with the name. What was the name? FDP, something like that.
Regression FDP.
No, not the regression one. I think we don't need that. We need the FDP one. Sorry. I think I am confused. Yeah, we don't need this one. We need the regression one. Just close this. Where there's Nifty and emerge. Is the name regression? No, this is Excel for FDP. I have to change the sheet. I'll just change the sheet to, I think, linear regression. Can you guys do that? So
Is
you have
it
to
Excel for FDP too?
Yeah, Sushma, it's that. I'm so sorry, I forgot. It is The one you are saying, FDP one. And you have to just select the preferred sheet. So it is, the preferred sheet is linear regression. Are you guys with me on this? You've opened it? So I'll tell you one thing. I did this research paper, I think a decade back. At that time, there were two stock indices that that were invented by Indian stock exchanges. One was those were for entrepreneurs, and that was the time when our prime minister was talking a lot about entrepreneurship, was bringing many schemes like stand up and startup India loan schemes. Meanwhile, the stock exchanges also started, window for SMEs, small and medium enterprises. So they even started, they formed an index out of that. One was Emerge, that was an NSC, that was a index for startup, SME index. Its name was Emerge, and the other one was on BSc, and that was BSc SME. Its name was BSc SME. So my curiosity was that these indices were very small because they had the values of startups, values of SMEs. So I wanted to know how vulnerable they were. I wanted to know whether the volatility of Nifty, being a very monster kind of stock indices, has an impact on the volatility of these small SMEs index. So this study I did, and it got published also uh, on Scopus. It's one of the Scopus Index journal. So I took two series. One was Nifty 50, the other was Emerge. And as usual, as I told you, I am in a habit of calculating the log returns, not the log transformations, but log returns, because it's a price data. So to reduce the non-normality issue, the variance issue, and also the to reduce the heteroscedasticity, I use the log returns. So this
Excuse
is
me, ma'am.
Miss
Yeah.
Akanksha.
Yeah, sorry, Silky ma'am, for interrupting you. As we are running out of time, so I just request you to please, wind up the session and just give a brief about those topics.
Give me 10 minutes, Akanksha.
Yeah, sure, ma'am. Thank you.
Okay, let me show you what I did and how you apply the Garch model, okay, without wasting time. So we go to we go to estimate equation. So this is, we are checking the clustering, volatility, and we write the equation. So let's say I wanted to check log emerge C log Nifty, and I don't change anything. I press OK. These are my results. I go to receipts. So this is my cluster volatility plot. These are my residual plots. I see that not a very fine one, but I could see that the period of high volatility is followed by period of high volatility. And see here, from 18 mid of 2018 to let's say 19, mid of 19, period of low volatility is followed by period of low volatility. So it shows that I can apply, it gives me a green signal that I can apply Garch model. So what I do, I go to estimates now. I go to estimate, and here I just pick up the arch model. And then it shows that you want to pick up the variance regressors. Even if I don't pick up, let's see what happens. Okay, I press OK, and these are my results. What are my results? My results are that my dependent variables log emerge. My Garch term is here, where there's a constant. This is my arch term recid. square. This is my Gauge term. I have no exogenous variables, okay, except log Nifty. And I see that the returns of log Nifty have a significant impact on the returns of log Emerge, which are very good results because Nifty is a big monster kind of a thing for log Emerge. Now, if I check my variance equation, I check that the Gauge term means the volatility of previous day has a significant impact on the volatility of today's of log emerge. And I also see that the return information of the previous day of log emerge has a significant impact on the volatility of emerge. So this is my arch term, this is my Gauge term, both are significant. Even the returns of Nifty are significantly impacting. I could have got log Nifty here if I wrote there in the regressor. In the variance equation, log Nifty would have been added and its significance. So what would I have said that time? That the volatility of the log Nifty is significantly impacting on it. So
Hello.
these are,
Hello.
yeah, Shankar.
Madam, is it positive or negative? I will say positive impact or negative impact will be intercept or only significant.
No, it is positive because the coefficients are positive, Shankar.
Based on positive coefficient sign, only positive impact and negative impact.
Yeah, that is the significance of coefficients while writing your paper.
Madam,
Positive and
how
negative.
much I write how much impact is there or not. If, for example,
Yes.
if 0.9 graph minus 1 is 0.90, if 1% increase in the previous day.
No. That you cannot check with the coefficients. You can just put it, and they are usually used for prediction, Shankar. That is, you're talking about adjusted R square, which is 10.47, which is not really very good. That means there are other variables also impacting emerge volatility.
Okay.
See, for that you have to take adjusted R square, which is 10.47%, which indicates the percentage change in the variance of emerge is 10% because of Nifty 50. But then the variables are only two. That means 90% is explained by those which you have not picked up. Okay. Is it okay, Shankar? Now, Alliance asked me that in regress, I told you Alliance just now that in regress, if you have included log Nifty, you would have got that result here below, below Gauge 1 model.
Yes, ma'am. Thank
Okay.
you.
Yeah. Any other doubt, anyone? So, guys, the organizers are scolding me for, stretching your evening so long. I'm so sorry. And Akanksha, thank you so much, dear, for sitting here so long. But initial half an hour was wasted, so I thought of just stretching the thing.
No, it's quite fine. Actually, it is actually a very interesting session, and even the participants are, curiously participate in it, posting their queries, and I guess they, they learn very much from this session. So, thank you so much, ma'am, for such an enlightening and a practical session. You start from forecasting model to the volatility patterns, and this session is all about the revision of the previous session, and that to focus more on the Gauge model. So thank you, Firdaus sir also. Firdaus sir is, also keep sitting for the last 3 hours also. So hand it to you, Firdaus sir.
So thank you very much. So we would request all the participants if they can on their videos while recording.
Thank you, Vikas. I'm sorry for extending it.
No issue, ma'am. It can happen. It was a technical glitch. So on my behalf of the technical session,
I also want to thank all the participants for making it so interesting. I was not expecting, so much of participation from Sushma said, then Kashmiri, and there are many more. Sorry, I am forgetting the names, not very good in remembering that. But really, I really enjoyed answering your queries. I hope you got the answers well.
Yes. So thank you all participants. Thank you for your active engagement. And don't forget to join us tomorrow at the same time for our session on panel data econometrics with Dr. Meenakshi. So stay tuned for the further updates. Thank you all.
I request you all to on the camera so we can have one group photo. Thank you very much. I was unable to unmute myself, so we can now leave. Thank you very much for your this long session and your hardcore patience.